And here we go. Exercise, this is 14J. They're asking you to sketch. Let's not sketch yet. I'm just going to try to find x-intercepts. Okay. Now, let's do, I'm going to pick one. Let's do E. Okay, I'm going to do E. E. You are trying to sketch the graph of y equals to 2 times cos of 2 multiplied to x minus pi on 3 minus 1 as well, and it is between, x is between negative pi to 2 pi. Okay, so another way of writing that is x is greater than or equal to negative pi and less than or equal to 2 pi. Okay, now, if we were to find x-intercepts, what's the very first thing you have to do? How do you find x-intercepts again?
Y is equal to 0.
Yeah, doesn't matter what equation you have, it is always the same theory. To find x-intercept, we know that the y-coordinate is always 0. So you say, let y equal to 0. So here we go. Let's start off with the first one. So I'm going to let y equal to 0. And I have 2 times cos of 2 bracket x minus pi on 3, close brackets, minus 1. Okay, it looks intense. What's looking intense is this section. Okay? What's not intense is the minus 1 and divide 2, or times 2. Okay, so most of you will be able to move the minus 1 and move the positive 2 there. How you would do it? Same thing, we'd solve as we usually do. Opposite of minus 1, add 1 on both sides. So you get 1 is equal to 2 times cos of 2 bracket x minus pi on 3. So just ignore this section for now. Okay, so we're just ignoring that section for now. The other part, this is currently times 2. The opposite of times 2? Half, or divide by 2. So we all know how to do that. We say, all right, divide 2 on both sides. 2 divided by 2 is 1, or cancels out. And so you get half is equal to the cos of 2 times x minus pi on 3. So up until this step, this is where it varies. So most students will be able to get up to this step. You need to understand what this means now. Okay, so this is where symmetry properties, exact values come in. So think of a unit circle. What you're saying here, or what you're trying to find is, you're trying to find x, which is an angle. But this entire thing is an angle, right? Cos of an angle will give you half. Now what does cos represent again? X. So you're saying, in this unit circle, x, because cos represents the x value, you're saying cos of an angle, so whatever angle it is, the x value is equal to half. That's a positive half. So in your unit circle, where is x on the x-axis? Where is it equal to half? Well, it's about here, right? So that's where x equals half is, but that means there's only 2 regions, or 2 points, where in the unit circle, it can be half. So this is what I'm picturing. I'm like, okay, that means if x is going to be half, say this is half here, that's where x is half. You've got that point and this point. Those are the only 2 points where x coordinate is going to be half. You don't care about the y. Who cares about the y? We're not interested in that. We're doing cos. And here Jules said?
Cos 60.
Cos 60. We know that cos is 60 degrees. So in this unit circle, I know that there was 60 degrees up and 60 degrees down. That gives me that point. And then the same thing with this point. But in terms of radians, we're talking about distance. From 0, I know that the radians for 60 degrees is what? Pi on 3. So I know it's up by pi on 3 or down by pi on 3. Okay? So now that I've got my unit circle, that's what we're trying to figure out. We're trying to figure out the answer that you go up by pi on 3 from the x-axis or you go down by pi on 3 from the x-axis. So here, now we can then try to solve. So we're like, okay, let's try to go back. I need to get rid of this cos, right? Because I want to find x. Just like what we've been doing, we've got rid of the 1, we've got rid of the 2. Now to get rid of cos, what's the opposite of cosing? Cos inverse. So here I go, all right, cos inverse the right, cos inverse the left. These 2 are inverses, so they cancel out. And this is where the step, I'm going to teach you my way of doing it, and then you'll see I'm going to do the same method for every other equation, and hopefully that is a method for you to work with. Yep.
Did you say the equation right to bracket x minus pi on 3 is equal to pi on 3?
Yes. Very good. So here, I'm just going to, exactly that. So I'm just going to pause for a moment here. What you're saying is correct. And I'm going to show you how I do it, but you're right. So pi on 3 is the first step. So here we go. This is where we're up to. This is what students generally find tricky, but all it is going back to what you've done with exact values and symmetry properties. We knew that cos inverse means cos of what will give you half, and exactly like what Jacob said, we already knew that from 0, I only need to go up by pi and 3. So use that as your first starting point. Doesn't matter. Okay, always just use, even if it's not in the domain, even if they said before, if they didn't say negative pi to 2 pi, if they said 10 pi to 12 pi, doesn't matter. I want you to find the first point that you know. And exactly that, the first point that we know was pi and 3, which is one of them. Okay, so that was from 0 going up. That was pi and 3, so 0 plus pi and 3 gives you pi and 3. That's how I got my first one. What about this other one? There's another point here. So I got this point up here, but I need that point on the bottom. What would this be? Yeah, very good. So you got many different ways. You can say negative pi and 3 if you wanted to. That's up to you. Or you can do all the way around is 2 pi, but then you know that you're short of 2 pi, so you're going down by pi and 3. You can write 2 pi minus pi and 3, which is why Jacob was saying 5 pi and 3. Or you could have just said 0 minus pi and 3, and then it's negative pi and 3. It's up to you. Doesn't matter. You just need 2 points. You needed one that represents the top, and you need one that represents the bottom. So I've chosen the top one to be pi and 3, and I'm choosing the bottom one to go with Jacob's one. I'll go with 5 pi and 3. Doesn't matter. Okay? Doesn't matter which one you choose. You can choose negative pi and 3, or you can choose 5 pi and 3. Same thing. Okay? So now I've got 2 points to represent it. This is where we now try to work with this section. This is where my method comes in. So 2 times x minus pi and 3. Remember the domain? The domain was from negative pi to 2 pi. Okay? I would actually, I know that the textbook may teach it differently. This is how I do it. I would actually just keep inversing it until I get towards x. That's what I would do. Okay, so I'll do exactly what we've been doing from the start. We got rid of the 1. We got rid of the 2. We got rid of the cos. And now I'm going to get rid of this 2. This is 2 times the bracket. The opposite of timesing 2, divide 2. So if I divide this side by 2, I need to make sure I divide both of these solutions by 2 as well. So 2 divided by 2 cancels out to be 1. My right-hand side is now x minus pi on 3. My left-hand side, this is where you have to be pretty good with your fractions. What's pi on 3 divided by 2? Pi on 6. For those who don't know, it's pi on 3. Remember division, you do reciprocal, so it's times half. And that's why it's pi on 6. And this is 5 pi on 6. Right? So remember, we chose 2 points. One for the top, one for the bottom. And then I'm just undoing every solution right now. I'm undoing the 2. And I'm now going to undo the last one. This is a minus pi and 3. So the opposite of minusing pi and 3 has to be plus. Add pi and 3. Okay, so you add the fraction. So here we go. I'm going to say add pi and 3, add pi and 3, add pi and 3. Okay, so we don't always have 2, but in this case we've got 2 solutions to start off with. And this is where I like to work this way. I like to make sure they're in the same denominators. So right now it's out of 6. So we'll think about it. Pi on 6, I'm adding an extra pi and 3, but we can convert pi and 3 into 6 to become 2 pi and 6. Have I confused anyone there? Because I know this is to do with fractions. All I did was I know I'm adding pi and 3. To make the denominators the same, I have to times the 3 by 2, times the top by 2. That's why I've got 2 pi and 6. Okay, so now I've got 2 pi and 6. So what I'm doing here is, I know that you're always going to be adding 2 pi and 6 for those solutions. So I've got added 2 pi and 6, and let's see. This now gives me, if I add 2 pi and 6, this will give me 3 pi on 6. 5 plus an extra 2 will give me now 7 pi on 6. This will give me 2 solutions to start off with. That's what you need. Okay, if you understood what I was doing there, I was just undoing the problem. So I zoom out just to see, for you to see what I did. I did get rid of 1, get rid of 2, get rid of cos, and this is where you had to use the exact values and symmetry properties. So we went over here. That was the hardest part. If you understood what you needed to find, there were 2 points that we had to find. So I used 2 points of reference. And it didn't matter which one. It could have been pi and 3 and negative pi and 3. It doesn't matter. You just need 2 points of reference. Yeah? So with this 2 points of reference, I then undid every other one. So I did, all right, undo the 2, undo the minus pi and 3, and this is my 2 points of reference. That is technically correct. What I don't know is, does this fit in the domain we initially said? So this is how I do it, okay? So with these 2 points, this is what I do. I will keep adding the number of cycles I need until I pass 2 pi, and I keep subtracting until I pass negative pi. That's how I do it, okay? And that way, it's always the same technique. You undo everything, you always have a point of reference, and then you use these 2 points of reference, and you keep adding the cycles and minusing cycles until you get them all. So the question is, how long does it take for this graph to make 1 cycle? That means 1 period. So this is where you go back to your exercise 14G. How do you find the period of the graph? So here we go. Period is always based on the end value. It's not based on that, it's what you're timesing to the x. And so it's that 2. So how do you find period again? Period is equal to 2 pi on n. Our n is 2, so it's 2 pi over 2. 2 divided by 2 gives me pi. So what does that mean? It means that in my unit circle, so remember the unit circle, we had 2 points of reference at this point and this point. That's what these 2 represent. One's the upper one and one's the lower one. So if I want to find all of them, all I have to do is take this point, which was 3 pi and 6, and I add pi. That gives me the next point. Then I add another pi, gives me the next point. I keep adding the cycles until I pass 2 pi. Then I do the same, I minus pi until I pass negative pi. But then you have to do the same for the second point. So you start off with this point, add pi, add pi, add pi until you pass the 2 pi point, and then you do the same, minus pi, minus pi, minus pi until you pass negative pi. All right? So what I do here is I like to convert pi, so the period was equal to pi. I like to convert that into 6 because that's out of 6. So how do you convert pi into 6? Well, that's just 6 pi on 6. So essentially what you're saying is if you want to find all the possible x values, all you're doing is you're adding cycles of 6 or you're minusing cycles of 6s. So here we go. Let's work out the upper one. So here's my upper one. I had 3 pi and 6 to start off with as my reference point. So 3 pi and 6. If I keep adding 6s, this is what I'm going to get. 3 plus 6 gives me 9 pi and 6. 9 plus 6 gives me 15 pi and 6. 15 plus 6 gives me 21 pi and 6. 21 plus 6 gives me now 27 pi and 6. And then 27 plus 6 again gives me now 33 pi and 6. And I can keep going. But the point is, where do I have to stop again? I had to stop at 2 pi. What's 2 pi? That's equivalent to 12 pi and 6. 12 pi and 6 is all I needed. Now I've gone too far. This 15 is above 12. 21's above 12. I don't need these. See, so you know where to stop. So I know that none of these solutions fit. I can take them out now. So that means these fit. 3 pi on 6, 9 pi on 6 definitely fit. But remember, I need to subtract. So 3 minus 6, let's minus 6 in that direction. So 3 minus 6 gives you negative 3 pi and 6. Negative 3 minus 6 again gives me now negative pi and 6. And then remember, what's my domain up to? It was up to negative pi. So negative pi has to be negative 6 pi on 6. I've already passed that. So that means that's out. So really, within that domain, for my first point of reference, I've got 1, 2, and 3 that fit. I now need to do the same for 7 pi and 6. Okay, so 7 pi and 6, I do it again. So here we go. We knew that there was the second reference. We had 7 pi on 6, and I do the same. The period was pi, so I knew I'm adding 6 every time. So here we go, let's do it. 7 plus 6 is 13. 13 plus 6 is 19. 19 plus 6 is now 25. But again, we had a point up until 12. So these can't be fitting it. That has to be in it. No. So then I minus now. Minus 6 in the other direction. 7 minus 6 is
12.
Sorry?
That's 13 and 12.
Oh, you're right too. Thank you. And then I was testing you, of course. So pi and 6, that's 1. Minus 6 in that direction, that gives me now negative 5 pi and 6. Minus 6 again, that gives me now negative 11 pi and 6. And that again is too far because we had to get up to negative 6 pi and 6. So after doing all of this, I know there's a bit of trial and error in each direction. There is a much more succinct way to do it, but this is the most direct way. So start off with this and you can play around with how your tutor teaches you. I don't mind. But but that's how I do it. That's the most basic way. Undo everything, add the pi's, minus the cycles, and you get all the answers. So if we had to write it all succinctly now, x was equal to, which ones can we have? We had negative 5 pi on 6. In the negative region, I also had negative 3 pi on 6. And I like to write them in order as well. And then after that, we had pi on 6. We also had 7 pi on 6. We also had 9 pi on 6. And that was about it. Did I write 3 pi on 6? No, I haven't. Whoops. I missed that one. Let's move that a bit forward. I like to write them in order. It's just me being able to double check. And of course, when you finish off your answers, you should simplify them. So I've got them all in 6s, so it's nice. And when you sketch, it's nice to have it in 6 because then the scale is nice. Okay, so here I can then say, if they only ask you for x-intercepts, then you should simplify them. It becomes negative pi on 2, pi on 6, pi on 2, 7 pi on 6, and then finally 3 pi on 2. Let's check our answers with our CAS. Okay, so once you've gone through all those steps, what was the hardest part, you see, was here. Was to get the first point of reference. Once you've got the point of reference, see, all I did was add on the cycle. Add on the cycle minus the cycle, and I've got all my points that I needed. Yeah, so this is my answer. Let's use our CAS. Here we go. So I'm going to go to my CAS, and I'm going to delete all of this. Here we go. Let's do it. So solve, menu 3, 1. So menu, type the number 3, type the number 1 for solve. And what are we solving for again? What was our equation? I forgot it. It was over here, 2 times cos of 2 times x minus pi on 3. So pi over 3. Whoa. Pi on 3. Close brackets minus 1. Okay, and remember we let that equal to 0. So equals 0. That's the equation. We're trying to find x, so comma x. Close brackets. Now don't forget, when you solve, you have to also give it a domain. Okay, because otherwise it's infinite solutions. So if you don't give it domains, you won't be able to solve it. So here we go. I'm now going to give it a domain. Control equals given. So I'm saying given that the domain was from negative pi to 2 pi. So here we go. Negative pi. X is greater than or equal to. And then it's also less than or equal to 2 pi. What's going on there? There we go. Okay, can you see what I'm doing there? So I'm testing now. I'm saying 2 times the cos of 2 times x minus pi on 3 minus 1 equals 0, comma x. Give them the domain. And let's see if I've screwed up. Sometimes I do. Here we go. Enter. And I have screwed up somewhere. Where did I screw up? 2 cos. Is it this bracket? No, that made sense, didn't it?
I have a second bracket on the other side of the pi.
Am I meant to have that?
You need pi over 3 in the second bracket.
2 times cos of 2 times x minus pi on 3. Oh, I see. Wait, no, that doesn't make sense.
Because you got another one at the end.
Take away that. Oh, there we go. Whew. Sorry, so my brackets were the issue. So be mindful when you put in those brackets how it works. But there we go. So let's see if our answers were correct. We had negative 5 pi on 6. That was one of our answers. We got negative pi on 2, correct. We have pi on 6, yes. Pi on 2, yes. 7 pi on 6. And there's an arrow to indicate that there's more. And let's just see if the last one is correct. Should be 3 pi on 2. Okay, so you can do it on your CAS. Practice doing it on the CAS to check your answers. But that is what you want to be able to do. That is at the year 12 level where they'll change the domain, but it doesn't matter what domain it is. If you follow that method, it doesn't matter what it is. You just need to undo the problem back and forth, and you keep undoing until you get 2 references or 1 reference. It doesn't matter. You need a point of reference and keep finding the cycles for all of it. That's essentially the skill.
I don't get how you got all those answers.
This one here?
I know 2 register.
Okay, so we got up to this stage here. Was it up to that point?
Yep, I get that.
Okay, so in the unit circle, what that point represents here is you started off with pi and 3 and 5 pi and 3, which represents these points. So that's pi and 3, and this is 5 pi and 3. Okay? Now, in a cycle, if you think about, this is a cost graph, so it goes like this, right? When you're finding the x-intercept, what essentially you found is the first point, which is at pi and 3. Now, when does this cycle come back to pi and 3 again? We know this point only comes back to the same point again after a distance of the period. So that's what I'm doing. What I'm doing is I take this point that you have and I'm adding on whatever the period is. But the thing is, this graph has a lot of transformations. There was a dilation of factor half. There was a translation of pi on 3 or whatever it is. So shift this graph somewhere else. So what I've done is I've taken our point of reference, okay? I've taken our point of reference and I've done all the transformations that we needed. So the pi and 3 now becomes 3 pi and 6. The 5 pi and 3 now becomes 7 pi and 6. So essentially in the graph, what I've done is I've moved it to where it should be. So if it's moved to the left by pi and 3 and it's shrunk, let's say it looks like this now, right? My 2 points of reference is now here and here. So what I did is I said, okay, now I've got the 2 points of reference. Let's find out how long it takes to add to that cycle. That's why I'm using not adding on 2 pi, but I'm adding the period of what it should be. This is the period. The period is calculated by the transformation and it's 2 pi by the dilation, because dilation is the only thing that affects the period. So that's why I knew the period was pi. I said, all right, so now that I've got the 2 points of reference, which we had as 3 pi and 6, 7 pi and 6. Okay, so I'm going to go back to our unit circle. I now have the 2 points of reference. This is now 3 pi and 6, and the other one was 7 pi and 6. I now know that one cycle, okay, one cycle, or on the graph, to reach back the same point, one cycle was pi. So I'm saying, all right, if I want to find all of the possible answers for the x-intercept, this is 1, plus pi will give me that point. Plus pi again will give me the next point. Add pi again, I'll get the next point. Okay, but that only gives me one of the points. I'm still missing this one. That's why I split it up into 2 sections, and I said, all right, well then 3 pi on 6, if I'm starting here, if I add pi to it, that'll give me the next solution. So when I say add pi, I said, since this is out of 6, it's like adding 6 out of 6. So I said, all right, well, all I'm doing is I'm just adding 6s. So 3 plus 6 is 9, and then 9 plus 6 again is 15, and then 15 plus 6 is 21. Oh, my pen's kind of going funny. Like that. That's what I was doing. And so that gives me all the possible solutions here, but I have to remember that my domain was from negative pi to 2 pi. So that means 2 pi, if it's out of 6s, I have to stop at 12. So that means those are out. That's how I had 3 pi and 6 and 9 pi and 6 as part of it. But then once I've done one cycle for this one, so I figured out all the possible solutions here, I also needed to find all the possible solutions for this one, plussing and minusing. So this one I added 6s, now I need to minus 6s as well. And that's how I got, if I minus 6, 3 minus 6 is negative 3 pi and 6, minus 6 again, that gives me negative 9 pi and 6, which is now too far from my domain. Okay, so the domain for it to be negative pi, it had to be restricted at negative 6. So that's why this is out. So now I've got another solution. So I've got negative 3 pi and 6, 9 pi and 6, 3 pi and 6, just for the upper half. Then the bottom half, I do the same. So here I started adding and minusing 6s. So I added 6, 7 plus 6 is 13, too far now, out of the domain. So then I minus 6. Minusing 6 gives me pi and 6, minus 6 again gives me negative 5 pi and 6, and then minus 6 again, too far. Wait, don't, now that's too far. So that means the only solutions I have now are pi and 6, 7 pi and 6, negative 5 pi and 6. So when I put them all together, I wrote it neatly. From smallest to largest, I wrote x is equal to negative 5 pi and 6 is the furthest. And then I went to the next one, negative 3 pi and 6